Let's talk about partial fraction decomposition. The decomposition we use depends on the type of factor that we're given. For non-repeating linear factors of the form ax plus or minus b, we decompose that into big A over ax plus or minus b. Essentially, we just throw a constant up top and we keep the denominator as that factor. For repeating linear factors, which come in the form ax plus or minus b to some power, we decompose into fractions where the numerators are all constant coefficients, a, b, c, and so on. And the denominators include that factor where as we move to the next term, we increase the power from 1 to 2 and so on until we reach the power that we were given on the original factor. For quadratic irreducible factors of the form ax squared plus bx plus c, where this cannot be broken down or factored anymore to look like some linear terms, we decompose it into a fraction where the denominator is that irreducible quadratic factor, and the numerator is a linear expression with ax plus b. A and b are what we're going to find. These are our constant coefficients. And our repeating quadratic irreducible factors, which come in the form ax squared plus bx plus c to some power n, where of course the inside here is a quadratic that cannot be reduced or factored. That decomposes into fractions with the numerators being these linear terms ax plus b, cx plus d, and so on, and the denominators being that quadratic irreducible ax squared plus bx plus c with increasing power until we reach the power that was given from the original factor. Hopefully we're noticing the pattern here. Linear factors have these constant coefficients, a, b, c, and so on, whereas quadratic irreducible factors have linear coefficients, ax plus b, cx plus d, and so on. We should also notice that the repeating factors behave similarly as well, where we increase the power of that factor as we create our denominators until we reach the power that we had started with. Note that in AP Calculus BC, you only talk about the linear non-repeating factor types, whereas in a typical Calculus 2 class, you'd cover all 4 factor types.